Hello everyone, let's solve this problem LeetCode56 merge intervals. Let's check this problem. The description of the problem is, let's see here, given an array of intervals, well, the intervals I equals to like this. There's a start point and ending point. Merge all the overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. Okay, here's the example. So we have 1, 3, 2, 6, 8, 10, 15, 18. So we can see here 2 is smaller than the previous ending of 3. So this part actually overlapping. And then we put the result of 1, 6. But this one, the 8 is greater than the 6. It's not overlapping. We put it here. And the 15 is not overlapping here. So that's basically the description of the problem. So for this problem, when we solve it, the first thing we need to ask the interviewer, is this intervals are solid? So because we need to analyze this question, right? This problem. So because in the description of the problem, it doesn't say these intervals are solid, right? But the example given is solid. So we need to ask. We need to ask first. Ask the interval. Are the intervals given solid or not? Okay. So if not, the first thing we need to do. We need to sort it. Okay. So if not, we need to sort it. Okay. And then we can always start analysis this problem using brute force algorithm. Here's the example. It's exactly this example. So what we do here is that we actually started from the first interval when I equals to 0, and then we will check all the intervals which interval is overlapping with the first interval, and then we check this one. Okay, so basically we can do something like this, and then we check this interval. If it's overlapping with that one or not, and then kind of like this. Okay, this is basically and then what we do, we check this interval. Is any interval with overlapping with that? So this is how we actually doing for the brute force algorithm. So the time complexity for this problem is gonna be O(n) log n plus O(n) square. Okay, so why? Because first we need to sort it, right? So it take O(n) log n to sorting this problem, and then we take O(n) square to do the kind of the brute force algorithm. Okay, so the space complexity will be O1 because we don't have extra space for it. Okay, and then the interviewer will ask us, can you do some another algorithm to optimize it? Yes, for sure. Yeah, we do. So what we do for this problem? Let's give these examples, right? Here is let's give this example. This algorithm 2 is optimal algorithm. So this is the input, right? So first, you still need to ask the interviewer: are all the intervals are sorted or not? If it's not sorted, so first we need to sort it. Okay, so let's say this problem 1, 3, 2, 6, 8, 10, 8, 9. See, it's not sorted, right? And then after sorted, it's gonna be 1, 3, 2, 6, 2, 6. 2, 4, 2, 6, right? This example. So I made this example longer. In this way, we can easily to understand the problem. So how do we do this problem? So first, what we do, we have a 2-pointer. We have the 2-pointer is one is the start, another one is the end. We are trying to recording the non-overlapping intervals. Okay, this is from beginning. Okay, so first we iterating all the we iterating all the okay. So first we need to sort it, and then we iterating the intervals to check if it's merged or not. Okay, so first we start from 1, 3. Okay, we start from 1, 3. And then we check if overlapping or not. Okay, 1, 3 and 1, 3, yes, still 1, 3. And then we check this one. And then and then we check this one. We check 2, 4. So how do we check it? So we will check the starting of this interval if smaller or equals to the ending interval of the previous one. So that means there's overlapping. And then what we do, we will update the maximum, whichever is greater between this interval and this interval. So which one greater? Obviously, in this problem, the 4 is greater, so we updating. So we just delete this part, delete this pair. We do 1, 4. Okay, and then we iterating one more. So we will check the 2 is smaller than the ending of the intervals. Yes. And then that means is overlapping here. And then what we do, we update the maximum ending interval between this interval and this interval. So we can see here is 6, here is 4. So we update here to 6. So what we do, we remove that interval, we update 1, 4. 1, 6, okay, and then we iterating one more. We check the 8 is smaller or equals to the 6. To the 6, no, it's not. So that means there's no overlapping in this case. So what we do, we just take this one, take 1, 6, and then what we do, we put it in the result. Okay, we put it in result. This is what we do, and then we will reassign the start and ending point. In this way, we will remove this one. So the start gonna be 8, ending will be 9. Okay, and then we will check. And then we do I++, and then we do check if 8 is smaller or equals to the ending of this interval 9. Yes, it is. So what do? We update the ending of the intervals here. Here is 9, here is 10. 10 is greater, so we take 10 here. So what do? We delete this one. We just remove that one. We update. Okay, so it's 8, 10, and then we I++. We will check 9 is smaller than the 10. Yes, that means overlapping. And then we update 10 and 11. Which one greater? Of course, 11 is greater. So what we do 8 and 11 here. Okay, and then we will iterating one more interval. We will check 15 is smaller equals to 11. No, that means there's no overlapping between this pair with this interval. So what we do here, we just put this pair to our result. Okay, and then we update our start and ending like 15 and 18 here. So okay, so and then we do I++. So we will check 16 is smaller equals to the 18. Yes, that means there's overlapping here. And then what we do, we just update the maximum ending of this interval and the pair we just recording here. So it's gonna be 18. Okay, so and then what we do, I++. Now I++, that means we after the iterating is over, like and then we add the last interval. So whatever left in the pair, we just add the last pair into the result. Okay, this is basically what we do here. Okay, and then we convert the array to and we convert this result to array and return it. Okay, so for this problem have to keep in mind here, like whenever the iterating ending, we will add the last pair to our data structure, because we are left in the pair here. We need to add it to here. Okay, so for the time complexity for this problem is gonna be O(n) log n plus n, and then y, because the first we actually sorted, right? The first step we sorted is take n log n, and then we iterating every single interval start from beginning to the end. So it take O(n) time. So the time complexity here is n log n plus O(n), and the space complexity will be O(1), because we don't actually use any extra space for this problem. Okay, so let's start coding. For this problem, it's very easy to use. So first, we will declare the list of array. Okay, this is the first. We will declare the list of array. We name it the result. We will store our result to the list of array. Okay, this part we declare list of array. Okay, and then what we do, we will check the corner case. So if interval the length equals to 0 and the intervals equals to none, this is a corner case. If this corner case, what we do, we return this one to array, and we will put a new inter 0. Okay, and then after we check the corner case, what we do, we array the sort. Intervals. We are sorting this one in ascending order. So what we do this way: 0 minus b 0. Okay, in this way we are sorting. Let's check if it's right or not. Yeah, you're probably right. Yeah, so this one we are sorting it. We're sorting it in ascending order. Okay, and then after sorting, we will initial the start and ending. So in this problem, we're gonna do interval 0, 0, 0. That's the starting point. That's the starting point of this one, right? So this interval is the interval 0, and this 0 is the starting point of that one. And if here is 1, that's the ending point. Okay, so what we do here is end equals to intervals. Okay, and then what we do, we are going to iterating the iterating the intervals, and then we check if it is merged, it is overlapping. We will check if it's overlapping or no. So for this, what we do a for loop, and here is int. These intervals here. Okay, we will check if the I0 similar equals to int. And then if overlapping, okay, well, what do we do? If overlapping, we update the end. We update the end and I here. Okay. We updated the end. We updated the end and the I1. So like here, we updated this one and this one. Which one? This one and this one. Which one? Whichever is the maximum. Okay. So in this case, it's 1,4. So we put it 1,4 here. So yeah, and then otherwise, if here is if overlapping, okay, so else if it's not overlapping, so what we do, if it's not overlapping, so what we do, we just put the result, we add it, we copy it and add it to the result we just did. Okay, so let's see here. Here we actually knew the list of, we declared the list of array result, right? So that's a list. Inside the list, there's a array. The type is array type. So, and when we do it, see here is the same. We just add this pair, the start and end to our result. This is basically a pair, okay? And then what we do, we update, and then we update our start. Start is gonna be 0. This is the starting point of the interval we are iterating, okay? And then the ending point is gonna be I1, okay? Yeah. And then what we do here, we actually did if no overlapping. If no overlapping, what do we do here? And then we reassign start and end. Okay, this is basically what we do here. Okay. And then what if they are equal? I mean, like what if we oh, not equal, yeah, so else is here, sorry about that. And then after we finish the iterating, you remember we have the last pair, we need to add the last pair to our result. This is basically what we do here. And then start and then this one we are added the last pair into result. Okay, and then what we do here, we are going to convert to char, convert to array. Okay, new into here is 0, and then yeah, something like this. Okay, convert to array and return. Okay, this is basically what we do here. Okay, let's run the code. Let's see if it's working or not. Here is not. What's that? Okay, this one is here is 1 second. This one is not. It's interesting. Here is not else if. If else if, that means we need to give a condition, right? So, but here is not else if. It's just else. Okay, let's run the code. Okay, it's accept. So the time complexity, we just talked about it, right? Is O n log n because here we just did a sort. Okay, and then after sorting, we iterating every single intervals in this array and in the interval array, and then the time complexity is O(n). So the total time complexity for this problem is big O(n) log n plus n. The space complexity will be O1. Okay. Thank you for watching. Oh, 1 second. Let me submit the code to see if it works or not. Okay. Our algorithm is faster than 99% of Java online submission for merge intervals. Okay, thank you for watching. I'll see you next time.